4.6, we're continuing on talking about our experimental design, and the first part of the notes really talks about the key principles of what you need to look for and talk about in an experiment. So sometimes you'll be asked to talk about, is this a good experiment, is this not a good experiment, so forth, so forth. So, the three things that you want to talk about, and we talk about the principles of an experimental design, are control, random assignment, and replication. When we're talking about control, we want to first of all have a control group, and then second of all, we want to try to set it up and have control those lurking variables. So when we design the experiment, we'll talk about things we can do to factor out things that could give other explanations to why we're getting the results that we're getting. The second thing we've been already doing in our experiments in 4.5 is that whole random assignment. Okay? You basically want to make sure, okay, that you do random assignment so that you can make sure that you can control potential other lurking variables that you couldn't necessarily control for in step one. So if a population has a certain characteristic that you don't want to factor out, if you do random assignment and your sample size is relatively large enough, hopefully you'll get an equal distribution of both within your two or multiple groups. The last part with replication doesn't mean we repeat the experiment over and over and over again. It means we just want to make sure that the number of experimental units or subjects that we have for our experiment is large, okay? Because the bigger that you can make it, okay, the less chance that a lurking variable, especially in the random assignment, can impact your experiment. Excuse me, as my voice goes again. So to show you some of these and what we're talking about here, we have this particular example. So it says, does caffeine affect pulse rate? Yeah, it might. So many students regularly consume caffeine to help them stay alert. Is that true? No, not really. Maybe. Mountain Dew, ring a bell? There we go. Okay? Thus, it seems plausible that taking caffeine might increase an individual's pulse rate. I know myself, I drink at least 1 cup of coffee every morning. One way to investigate this is to have volunteers measure their pulse rate, drink some cola with caffeine, measure their pulses again after 10 minutes, and calculate the increase in the pulse rate. Explain how to use all three principles of experimental design in this caffeine experiment. Excuse me.
Getting choked up about this.
I know.
Caffeine this morning. You didn't make any coffee this morning. You know that.
I know that, but I was up at 3:30 this morning and had a half a pot this morning.
Me too. I couldn't sleep. I was kind of rattling. I had a meat scenario last night. I just couldn't get it off my mind.
Couldn't get it off your mind?
I couldn't actually.
Well, for me I was not feeling so well. I went to bed like at 8 o'clock, and so I just woke up at 3:30, and I was awake.
Well, I'll tell you what. Let's see what it's like in here. Here, ready? Some water.
Yes, you did. You bathed them in water. Yeah, I was going to say. Anyway, getting back to this, first of all, one of the things that we want to do in the control part is make sure that we have a control group. Meaning, we want to make sure that in this experimental design, we're going to have students try colas with caffeine, and we're going to have a group of students that actually drink colas, but the cola is going to be decaffeinated. So you're going to have a caffeine-free cola group. Okay? Then you want to start to control for some lurking variables. Now, do you have to write all of these down? No. You can summarize a few of them. I hope you take some of those and pass them around to some of the other students. So, yeah, I know I'm recording. This is going to be a fun one. I might have to report it again tomorrow.
Or anything.
Or just add them.
graham cracker?
That takes too long. Yeah. No, I should make Mr. Harris do it. But some of the things when you're setting up this experiment that you should at least try to control for, okay? The amount of colas that the subjects are drinking, that really needs to be the same. Because if you give one group 8 ounces of cola and the other group 4 ounces of cola, okay, the amount of caffeine they're receiving is going to be different. They should also be served at, say for instance, the same temperature. Okay? Because since your body might metabolize it faster or slower depending on the temperature the cola is served. Okay? It should also look and taste exactly the same. That way the person doesn't think about, ooh, wait a minute, I'm not getting the caffeine cola. Okay? So the caffeinated cola and the or non-caffeinated should taste the same. It should look the same. Okay? How they drink it, the speed at which they drink it, you could control that. Okay? Now, is this everything? Probably, I'm sure I'm missing something, but if you can control these, it should at least give you a better idea, okay? Or a better sense, does cola or does caffeine actually increase one's pulse rate? Now, the next part is random assignment. So if you randomly assign them to the 2 groups, one of the things that the random assignment's going to help hopefully do is it's going to distribute some of the variables that you might not be, or lurking variables that you might not be able to control, right? For instance, you might not be able to control a person's caffeine tolerance. Some of you might be in this room, might be impacted by just drinking, 1 can of Diet Coke might cause you to, get the caffeine shakes. Well, you start, I've had way too much caffeine. Some of you might have to drink 4 or 5 cans of Diet Coke or Mountain Dew just to stay awake. So if we do random assignment and we have, a good amount of subjects, hopefully those that have high tolerance and low tolerance are distributed to both groups. We also mentioned like body size, the amount of food recently eaten. So you could potentially, the food eaten could control that by requiring that all subjects don't eat for the last 3 hours. But that's still going to be hard because maybe they haven't eaten for 6 hours or 8 hours or 10 hours. So the replication part, again, helps in reducing basically the variability that can occur due to random assignment. Okay? So if you can have large sample sizes, then the likelihood that caffeine tolerance or the amount of food eaten or body size will impact our results. So having 30 subjects and then having 300, we definitely would like to have the 300. However, what happens in real life is to run an experiment with like 300 or 500 or 1,000 people and to do an effective experiment can cost a lot of money. Especially your pharmaceutical companies that are doing, preclinical and phase 1 and phase 2 and phase 3 trials as they increase their sample sizes. For some companies to run a phase 3 trial, it can cost tens of millions of dollars. So if their drug actually passed the FDA and they find a cure for cancer or a cure for hepatitis, diabetes, you name it, some of the reasons why they charge a large amount of money is they're trying to make back all the money they spent on it. Of course, they're also trying to make a profit. Flip to the back side and see how far we get on this. I'm hoping to get it done, but I realize I only have like 3 to 4 minutes, so oh well. All right, so the last couple terms that we'll talk about with experimental design, at least for today. Okay. The first couple up here are placebo and placebo effect. A placebo is simply a fake treatment. And the placebo effect is basically when you get better off a fake treatment. Have you ever received a fake treatment in your life? I'm almost guessing you have. I give my daughter Sophia a fake treatment all the time. It's called a kiss on her owie. Okay? When she gets a boo-boo and she like runs in the house, or Dookie, who's our dog Duke, good, bit me, you know, I'll like where, and there'll be a little tiny scratch on her finger, and I'll kiss it. I'm like, does it feel better? She's like, yes.
I would believe that is a fake treatment. It works.
Okay. But I would suggest that it's a placebo effect. You believe that it works. Okay? So, now another type of term that comes up with experiments is what's called a double-blind experiment. A double-blind experiment simply is where you set up an experiment so that the subjects and the people who evaluate the experiment do not know what treatment they're getting. Ideally, this is what you want to make sure you do so that the subject and the evaluators don't influence the results by their psychological bias or whatever bias that they might have. So when, you know, companies want to like show that their product is better, ideally they should have an outside organization do the evaluation. So every time I hear a study or something about that was done, if it's done by the organization, I'm always a little bit leery about it. Okay? So, the other term that comes up here, I'm just going to mention it very briefly, is called statistically significant. What it means to be statistically significant is when you get results that are vastly different than the other. So like in a weight loss program, if one of those low carb, when we did the low carb, low fat, and control group, if the control group lost an average of 3 pounds, while low carb lost 4 pounds and the low fat lost 5 pounds on average, yes, the low fat did better than the other two, but was it significantly different? If I were to redo the assignment, would I get those same results? Okay? Possibly not. It could be due to just how they were assigned to their groups. When we look for something statistically significant, we're looking for a great amount of differences. I guess I'm going to be stopping there anyway, since Denise, go ahead. Yep, Kenzie is here.